Hello guys, you are welcome back to the second part of the video where we are making a review whether a concealed beam is more economical and stable in comparison with that of a drop-in beam. So in the last video we've made all the parameters that will be used to determine the economic and the stability of a concealed beam, and now we'll be doing the same thing for a drop-in beam. Okay, so this is the beam in particular that we are working with. The dimension here is 450 by 150. So now I'm going to double click on the beam, and then I'm going to change the dimension. I'll just interchange this. I'll change this to 150, and then I will change the height to 450. I have to twist around the dimension so that the comparison can be perfect. I cannot just bring in another kind of value if I am making a review. Alright, so just click on update and click on yes. Alright, then you can close that. Alright, so that is good enough. Now we have to rerun our analysis and then our design. So go to analysis and then building analysis. Just go to analysis directly and building analysis, beam. So click on this. Now let's wait for the analysis result and the design result. Okay, so it has been completed successfully. Just click on close, and then I can go to post analysis, go to beam reinforcement, and then I can go to the last beam, which is beam 147. Then just double click on it so that I can open that. Okay, fine. Now you can see the result. You can see the number of reinforcement we need. We need a total number of 4. We need 2y16 at the top and we need 2y16 at the bottom. So that means to construct this beam, we will be needing a total of 4y16. Also, you can take a look at the deflection of the beam. You will see that the deflection of the beam is 10.3. That is the deflection of the beam. And the permissible, which is the limiting value, is 45.58. You can see that it is not even close to the limiting value. So everything here is just good. You can see there's nothing like red, just like we had it in the previous one. Okay, so now we can close it. We've checked the number of bars. Now we have to consider the moment of inertia, and we also need to consider the load carrying capacity. Okay, so just click on OK, and then you can close this. Also, you can close this. Alright, so this represents the cross section of the beam. You can see that the depth is 450 and then the width is 150. The moment of inertia, the formula is still remain the same, bh cube over 12, and then if you put the value here, you will arrive at 11.4 times 10 raised to power 8 mm raised to power 4. So this is the value for the moment of inertia. Also, the load carrying capacity, the compressive load divided by the surface area. Okay, so that is 5,000 kilonewton load divided by the surface area. We will arrive at 7.92 newton per mm squared. So this is going to be the load carrying capacity for that cross section. So now that the parameter has been established, we will have to make the comparison, and then we can go ahead with the conclusion. In a tabulated manner, you can see the column for the concealed beam and the column for the drop-in beam. Now, if we consider the number of rebars that will be required to make one concealed beam, we'll be having 12 number of y16 reinforcement. Okay, and if you want to have a drop-in beam, you'll be having 4 numbers of y16. So you can see that you will need times 3 of the reinforcement that can be used to create a drop-in beam. You will need times 3 of it to create a concealed beam. So it is more economical for you to go for a drop-in beam instead of going for a concealed beam. So a concealed beam is not in any way economical. So that is our first review in terms of economy. We've made the conclusion that a drop-in beam is more economical than a concealed beam. Now let's go to the stability. We will first of all talk about the moment of inertia, which is necessary to calculate the deflection, necessary to calculate the flexural rigidity, necessary to calculate the buckling, and necessary to calculate the bending stress. Okay, so now what is the moment of inertia for a concealed beam? The moment of inertia for a concealed beam gives us 1.27. whereas the moment of inertia for a dropping beam gives us 11.4. 11.4. Now 11.4 is about 9 times greater than 1.27. You see, 11.4 is about 9 times greater than 1.27. So in order to achieve a moment of inertia that will give you the kind of stability that a dropping beam will have, you will have to increase your moment of inertia from 1.27 up to 11.4. Now, can you imagine the number of reinforcements and the quantity of concrete and even the width of the beam that we take in order to achieve this? You would have wasted a lot of concrete, not even reinforcement this time. You waste concrete, you waste reinforcement. So practically and economically, you will never achieve the moment of inertia that you will achieve when you are using a dropping beam. So you will always have a disadvantage in your deflection, you have a disadvantage in your flexural rigidity, and you will have a disadvantage in bending stress if you are considering using a concealed beam rather than a dropping beam. So it is not economical and it is not even as rigid as a dropping beam. Also, let's consider the load carrying capacity. The load carrying capacity from that specimen that we use, that particular beam, it is calculated to be 2.64. And what about dropping beam? We had 7.92. Obviously, 7.92 is 3 times more than 2.64. So that tells you that a dropping beam has a load carrying capacity of 3 times than a concealed beam. So in terms of economy, a dropping beam is better. In terms of stability, a dropping beam is better. So this brings us to the end of my review on concealed beam. So if you have any question or comments concerning my review, you can put it in the description box. And if you have something else you want me to review, you can just give me a call or a text to my email or my WhatsApp, or you can even drop it in the comment section. I will go through everything. So if you like this video, make sure you give it a like, and if you haven't subscribed to my YouTube channel, kindly consider giving me a subscription. Thanks for watching.